Here we have an absolute value equation. We're going to solve that for x, and we will have potentially two values for that variable. The first step that we're going to have is to isolate the absolute value, in this case the absolute value of negative 3x minus 8. So we will just treat it like a two-step equation in that regard. I'm just trying to get this by itself. So the first step will be to get rid of that constant using addition or subtraction. And negative 4 minus an additional 8 is negative 12. And then division of the left-hand side by negative 2 to cancel, and the right side as well. So now we've got a simplified version of this. Absolute value is all by itself, and we have 6 on the right. Now, if we had an inequality, we would definitely want to remember when we divide by that negative, it's going to switch directions. Here, that doesn't need to be considered. So the second step now will be to remove the absolute value and add a plus minus to the constant. So the theory that's going on here, what's going on here is that this is outputting a positive no matter what we have inside, positive or negative. So inside here we might have a negative 6, we might have a positive 6. Either way, the absolute value is changing that to a positive. So if we kind of take a step back and remove the absolute value, we're saying that this expression inside there could have been positive 6 or negative 6. Now we do two-step again, but it's good to split this into separate equations. So negative 3x minus 8 equals negative 6, or it could be negative 3x minus 8 equals positive 6. Doing each of these as that two-step equation, we'll have the same two steps, but just different results. So on the first one, we've got negative 3x equals 2. On the second one, negative 3x equals 14. And now divide by negative 3. To get the two solutions, we're going to have x either, and neither of these really simplifies, either negative 2/3 or negative 14/3. Usually we just do a comma there. Not in parentheses, it's not an ordered pair, we're just listing the two solutions. It can be helpful to visualize these problems. I like to do it once I've isolated the absolute value. Kind of makes a lot of sense for me to graph it there. So right after that first process, but you could graph it all the way back here too. The idea for graphing is when we have an equation, set y equal to the left and set y equal to the right, and then see when those heights match or when the lines cross. But like I said, I'm going to go down here because it makes a little more sense to me. Negative 3x minus 8 in the absolute value. And the other one is y equaling negative, positive 6. So now we can see the absolute value equation or graph is a V. And that's because really if it didn't have those, it would be basically y equals mx plus b. It would be slope-intercept form. And we would see it's a down slope and it crosses the axis here. The thing about it is we'll never have this negative. So when we start spitting out a negative y, the absolute value will reflect it or bounce it off the axis and make those positive. So it's kind of a reflection. And that's why I like to start here, because it's going to land right on the axis. If I chose to start all the way at the beginning, this is going to be out in space somewhere. So then what we're doing is we're saying, you know, here's our left hand of the expression or of the equation. When does this equal 6? Or when will it cross the line y equals 6? And we get negative, this one negative 14/3, I believe. Let me check it. That's negative 4.6 repeating for x, or 3/2, 2/3, I think. 2/3 is the other one 2/3 is up here, and that was also negative. So those were the two points where those cross, and I'm just going to finish this up and put those as my ordered pairs where they cross. These are when y equals 6, or in other words, when the left side of the equation equals 6. That's our solution, the x values. Next, what I want to do is look at that same basic idea, but what if it was a greater than sign, or what if it was a less than sign? Okay, so I'm starting at the beginning with that. The first example I'm going to do is going to have a greater than sign. And the steps are the same until we get to the point where we drop the absolute value and add a plus minus, because we will need to factor in the fact that we're not just equaling the right side, we could have greater than, less than, greater than, equal, less than, equal. So the first step is to subtract 8 from each side, just like before. We do have a negative on the right, but with addition and subtraction, that's not going to mess with our inequality. It's only going to be here when we do our division. We divide by -2, we're going to flip. And I usually just write the word when I do the division. And then in the next step, I actually go ahead and flip it around. So now what I'm saying is, when is the left-hand side below a value of 6? Looking at the graph, we can see that we're below a value of 6 when we are in between those two dots. So we want a value of x that's bigger than -14/3 but smaller than -2/3. And I think that graph can really help us to visualize that solution. So it's going to be a range of values in between, and that's when the red is below the blue, or in other words, the left side is less than the right side. So this one's red, it's got to be below the blue. Now the step is actually this. We do the plus or minus again, but the problem is when it's already got to be less than 6, and that needs to be true whether there's an absolute value or not. So what I usually do is kind of almost start on the right, copy it down, and then now we kind of reflect it to the other side. It still has to be the same direction because we go small to big, and so we're saying between -6 and 6. And this is going to set up that tripartite inequality, which will give us x sandwiched between two numbers. So now we do a two-step type of equation. Now it's an inequality, though, with that -3x minus 8 in between a -6 and a 6. And anytime you have a problem where it's an absolute value less than a number, you can always do that. Let me actually write this a little different. Let's say it's absolute value of, I'm just going to put x, y, z. We have something going on inside there. It's always going to be sandwiched between the negative version of the number and the positive version of the number. So that's always going to be true. If you add an equal sign to this, you add an equal sign to everything. So if it was a less than or equal, you could put those in. Let me just show, for example, in yellow, all of those would go in there if that's what we had from the start. All right, so let's just get rid of those so they're not distracting us. And I'm going to go to the next page and solve that. First step, add 8. Always deal with the constant first, then the coefficient. And we have 2 less than -3x less than 14. And now divide by -3. And just like before, make a little note for yourself. All the inequalities will flip when you divide by a negative. If you don't, it's not going to make any sense. And I'll show you why, it won't make sense. You do have to think a little bit about it. But here's -2/3 on the left is greater than, when I flip it, x is greater than negative 14 thirds. And so the arrows really should always point left because that should be the smallest. This is the small side, this is the big side, and that is smaller. So we go ahead and flip the whole thing all the way around. That way this is the smallest one, this is the biggest one, and 14 thirds was there, 2 thirds is there, we're in between there. In interval notation, we would do open intervals because this does not have that equal component underneath the inequality. That would be my final answer there. And so kind of what we're doing back here is we're really saying that the negative 3x minus 8 needs to be bigger than negative 6 and it needs to be less than 6. So if you did a review assignment, you might have gone through those problems with and versus or. This is an and I usually skip the and step and go right into that tripartite inequality. That's the most common way. Now I'm going to actually go back to the beginning and repeat this. The steps are all the same, so I can kind of skip through a little bit of it, but let's say it was a less than all the way back at the beginning. And we could even do a less than or equal sign to give it a little more variation this time. So the first two steps, we can look back at what we did. Minus 8, divide by negative 2, flip the sign. So kind of the same thing's going to happen. We're going to do a minus 8 and get the negative 2 absolute value, negative 3x minus 8, negative 12. Let's go to green again. Divide by negative 2. And we have absolute value of negative 3x minus 8 greater than or equal to, I forgot to write flip, 6. So now if we try to do that the same way and we put a negative 6 on the left, you'll notice that the arrows are pointed the wrong way. Back here, negative 6 on the left, less than sign, expression, less than sign 6. So small to big, small to big, small to big. It's almost like this sign itself goes small to big as you go left to right. Now we are backwards, so it wouldn't make any sense to do this because this should be the way that's written, the biggest number. And so that's one indication that we're going to have to do it differently. And if we look at the graph, we graphed this already. The absolute value is in red. And we're trying to figure out when the red line is greater than or above. This is the blue line. Let me just write those here. Red above or equal to blue. So it's basically when the red is above the blue, it's got to be on the left of there or on the right of there. Or it could be equal, because that is included. It's an inclusive inequality. So here's the trick. Here's what we do. We're still going to do a plus minus 6, but we're going to split it into two separate inequalities with an or. We keep it exactly how it is for the first one. And if you remember back here, I started by saying let's keep it first exactly how it is, just without the absolute value. And then let's bounce over to the other side and sandwich it. So we are going to have that same property here. Start by keeping it how it is, just without the absolute value. Negative 3x minus 8 greater than or equal to 6. Or rewrite everything and just flip the sign and flip the inequality. So change it from a positive to a negative 6, and we're saying it could be above positive 6, or it could be below negative 6. And now we solve these two inequalities with those same two steps. And it is adding 8 and dividing by negative 3, making sure we flip our inequality direction around when we divide by that negative. So that will be the next step. Divide by negative 3. Flip. And we get our final answer. X can be less than or equal to negative 14 thirds or it can be greater than or equal to negative 2/3, and that will be to the left of this intersection point or to the right of this one for our final answer. In interval notation, we would start all the way at negative infinity with an exclusive or open end. We would go to negative 14/3 with a closed inclusive inequality because of the equal. And then we have the union, which is for the or. That's called union. And then from there we'll go to 2/3 and to infinity. So there's a few examples showing you kind of all the different ways that these problems can go.